Hi friends, so we are going to see the lecture number 2 on strength of materials, that stress strain diagram. See, in last lecture we have learned what is meant by stress, what is meant by strain, and then we have seen the relation between the stress and strain, and that relation is nothing but stress is proportional to strain. And if you remove this proportionality, then it becomes stress is equal to modulus of elasticity into strain. Means we know that stress and strain are proportional to each other. So if I plot the graph of stress against strain, then stress on y-axis and strain on x-axis, then for mild steel material, so here I am going to write the MS, that is mild steel material. If I plot this graph, then initially we'll observe the straight line, that is stress is proportional to strain. So after that, if you increase the force value, then we'll see this graph. Okay, now there are number of points which are on the graph, and that we are going to see. So the first point on this graph is this one. I'll mark this point as A, the next point as B. Now what is meant by this A, what is meant by this B, that we are going to see. See, up to this A point, you can see the graph is straight lines. Straight line means stress and strain are proportional to each other. So you can see with the increase in stress, the strain is also increasing in this direction. So A point is called proportionality point. Up to this point, the stress and strain are proportional to each other. Then the next point is B. This B point is nothing but elastic limit point. Means up to this point, if I apply the force on the material, then material will elongate, and if I remove this material, then that material regains its original shape and size. So up to B point, if I apply the force, material will elongate. If I remove the force, material will regain its original shape and size, means the elongation is elastic. So this B point is called elastic limit point. Then this next point C and this point D, these two points are called yield points. But this C point is upper yield point, and this D point is lower yield point. Now what is meant by yield? Yield is nothing but with the application of force, if the straining is rapid, then that point is called yield point. Means after this point, if I apply small amount of force, then the straining will be more. So here you can see up to A point, the stress value is more, but the strain value is very much less. And after that, the stress value is small, but strain value is more. Means with the small amount of force, the straining is rapid, and that point is called yield point. And we observe upper and lower yield points in case of mild steel. Okay, so here with the small amount of change of force, the straining is rapid, so it is called yield point. Then the next point is ultimate tensile strength. So I'll mark this point as E. So E is nothing but ultimate tensile stress. This is the maximum stress value up to which the material can sustain. So this is the maximum stress value up to this material will be sustained. So it is called upper yield point. Then this graph moves downward, and the next point will be F, that is the failure point. F is nothing but the failure point where material fails. Now this graph, if you see, then it moves downward after ultimate tensile strength, because during the test, normally this test is carried on ultimate universal testing machine, and in that universal testing machine, whatever the specimen that we are going to use, that specimen after the application of force, it will starts to elongate, and when it reaches to ultimate tensile strain, then the necking will be generated, means the cross section here will be generated and material will be failed because of the self weight. So this is the failure point where actually the material is going to break. So this is the stress strain graph, and normally to draw this graph we use the universal testing machine. So UTM machine is used, and on that a dumbbell shaped a standard specimen is used, and these are the different points. These are the different points on this stress strain diagram, where you can see this A point. Up to this point, the stress and strain are proportional to each other. After that, the next point is B, means it is the elastic limit point. Up to this point, if I apply the force and remove the force, then material will regain its original shape size. Then next point is C. C point is nothing but the yield point, where with small amount of change in force value, the elongation will be rapid. Then next point is D. D is nothing but lower yield point. Then next E point is ultimate tensile strain. Up to this point, if I apply the force on the material, then the material will be sustained. And last point is F, where the material will be failed. And this diagram is for ductile material, means the material that we have selected here, mild steel, is ductile material. Okay, so normally this diagram we draw for the ductile material. Now in some examinations, along with this diagram, draw ductile material, draw the stress strain diagram for ductile material and for brittle material. Sometimes it is asked. Now what is the difference between this diagram and these two diagrams? See, mild steel is a ductile material, but in mild steel you are going to observe the two yield points. But a normal ductile material, consider aluminium. In case of aluminium, we are going to observe only one yield point. Now I am going to draw the diagram for the ductile material. So suppose this is the stress, this one is the strain, and if I plot the graph, then the graph will be like this. Initially stress is directly proportional to strain, then it will bend on the downward direction. Now here again you can see there are number of points. Here it is ultimate tensile strength, here it is the failure point. Up to this point it is proportional, stress is proportional to strain, then elastic limit, but here we don't have the yield point. So yield point normally we observe only in mild steel material. Okay, so we are not going to observe in other ductile materials. So here we'll have to determine that yield point. Now how to determine this yield point? So to determine the yield point, just check the strain up to failure point. Just check the strain up to failure point and mark 0.2% of strain. Mark 0.2% of strain, and then draw parallel line to this initial stress strain line. Draw parallel line to this initial stress strain line, and where it is going to, sorry, I am going to change. Okay, now where it is going to cut to this stress strain line, this stress is nothing but your proof stress, and this point is nothing but your yield point. So to draw the yield point on ductile material, we will have to mark 0.2% of strain, draw parallel line to this initial line, then it is going to cut, and that point is nothing but your yield point. Okay, so this is the diagram for pure ductile material. The above diagram is for ductile material for mild steel. Now the next diagram I am going to draw is for the brittle material. So again I am going to draw diagram for brittle material. The graph will be straight line, and here it will be failed. Now for brittle material, if I apply the force on material, yes, there will be elongation. So you will observe the point A, you will observe the point B, and directly you will see the ultimate tensile strength and the failure point. Means if I apply the force on the material, then without indication material will be failed. Means with small or negligible deformation the material is going to fail. So here you cannot see the graph where the strain will be more. Okay, so with less strain or negligible strain the material will be failed. Okay, so this is the diagram for brittle material, this one is for ductile material. Okay, and this diagram is normally called stress strain diagram, but it is actually of mild steel material. Now if anybody asks about the stress strain diagram, then you have to draw this diagram, along with you have to explain all these points. Okay, thank you.